In this video, we're going to look at the basic building blocks of statistics, data. So we're going to look at some examples of data, we're going to look at some components that make up data, and then we're going to look at some ways of visualizing data. So let's get started. Let's start with a discussion about what statistics is. Statistics is the science of data. What that means is we take a bunch of information that comes in the form of data and we try to extract useful pieces of information about that data. And then we use that information to either better understand the underlying relationships of the variables we're interested in, or to inform decision making in a more scientific manner. And so statistics really does revolve around data. So data by itself, it is actually plural. That's why we're using are instead of is. And before I go ahead and show you the definition, I'd like you guys to think about what data might mean to you. I'm sure that in your day-to-day life, you've had exposure to data of various forms, maybe in your other classes, maybe as part of your daily routine, you're actually collecting some data. So let's take a look at some examples of data sets in R before we talk about exactly what constitutes data. So there are actually some built-in data sets in R. So for example, we have a Fisher's iris data set, and if I just type in iris, it's going to spit the whole thing out. Okay, so you can see this is a data set collected which contained information on 3 species of iris flowers. We actually have Setosa, versicolor, and virginicas here. And what you also have are pieces of information about these different flowers, sepal length, sepal width, petal length, and petal width. Okay, so when you type in the name of a variable in R, if it actually exists, R will give you exactly what's in that variable, and it's not going to hold back and sometimes print way too many rows than you can process at once. What we also have in R is access to a Mosaic data library. So this is actually quite nice because it's got some really interesting data sets. So I just have to type in library Mosaic data to load in this package, and then I have access to all of the data sets that live in here. So I'm going to take a look at a CPS 85 data set. But instead of actually typing CPS 85, because I don't really want to see the whole thing at once, I'm going to use the head function to examine just the first 6 rows of this data set. So looking at this, you can see perhaps maybe making a guess here that every row in this data set corresponds to a certain individual. I'm making that guess because I have information about age, about experience, marital status, race, sex, education, and so on. And sure enough, because this is a data set that is built into R, I can actually look a little bit more closely at this data set by popping in a question mark in front of a variable name. And it tells me that this data set came from the 1985 Current Population Survey, so it's something like the census, where we have information on a variety of individuals. Okay, so here's one possible definition. You might think of data as a collection of information on a group of individuals. Now, I'm being intentionally vague here. Information can be anything. It can be numeric values, it can be categories, it can be any sort of information that you think might provide some insight on the research question at hand. And now a group of individuals, that can also be individual people, it can end up being animals, it can be items, it's really whatever you're trying to study. Let's move on to some terminology. So the smallest unit of data in a data set are what we call these cases. So if you look at a data set, what you have in each row is a single case. This is the information about a single individual. Okay, so you really have a lot of cases going on here. And each case will provide you information on a set of values relating to that individual. And then a group of cases makes up a sample. What we have for that sample is it resides in a population. Okay, so here I've got my population. And a lot of inferential statistics revolves around taking a good sample that is representative of that population, and then trying to study the relationships from that sample to make inference about the population from which that sample came. So variables we can think of as, well, there's really two primary kinds of variables, and we're going to get into this in the subsequent videos. So we have quantitative variables. These variables are going to be numeric in nature, so things like age, like height, like weight, like test scores, these are all numbers, so these most naturally become quantitative variables. We also have categorical variables. Now these are variables that naturally reside in categories, so you might have things like gender, or a favorite color, or a favorite band, or class year. These are things that are naturally formed into categories. Now sometimes it's not immediately clear whether a variable is quantitative or categorical. You have to think a little bit. So something like a zip code, for example. Finally, let's look at some ways in which we can visualize data, because for all intents and purposes, you're not going to be looking at a data set from beginning to end just by looking at each of the individual observations. A good data set might actually include something like 100, 200, 1,000 observations or 1,000 cases, and there's no way you're going to be able to get any meaningful information by looking at those values one at a time. So let's take a look at some ways of visualizing data. So I'm going to step back into looking at the IRIS dataset for a moment. And let's see, so a straightforward way of looking at a quantitative variable is to maybe look at a 5-number summary. And actually we can beat that by using this favstats function. So I'm going to type in a couple of lines of code. Don't worry about actually being able to replicate what I do in R right this moment. I would just like you guys to observe what comes out after I type these commands. I'm going to do ~sepal with comma data equals iris. What I'm going to get is some pieces of information about the quartiles, the minimum, the maximum, the mean, the median, the standard deviation, and so on. Now, when dealing with a categorical variable, I probably won't be able to calculate a mean, say, for the species, right? Because these are just labels. So what I'm going to do instead is use a tally function to get what we call a frequency table for something like species. And you can look at the breakdown of species in our data set. So it turns out we actually have 50 flowers from each of the species. Now this is another piece of information you probably would have a hard time figuring out if you were just looking at the data set row by row. What about some plots that we can use? So in terms of our quantitative variables, we can certainly look at a histogram of, say, sepal width to get a sense of the overall distribution. Okay, so this will tell us, for example, that the median width seems to be around 3 units. I have to look at the help file to remind myself of what the actual units are here. But 3 seems to be a good measure of the center of the sepal width here. And we can also see that this distribution looks fairly symmetric. Okay, we're going to learn some new words about describing such distributions later on, but I just wanted to give you guys a little quick sneak peek here. If we wanted to look at the relationship between two quantitative variables, we can use a scatter plot, which in R is called an XY plot, and we could do, say, sepal.length tilde sepal dot width, data equals iris. And this will show us a point for every flower in our data set where the y coordinate corresponds to sepal length and the x coordinate corresponds to sepal width. Okay, and we can even throw in some information about the actual species as well if we wanted. So what I'm going to do is add in a grouping variable called species, and I'm going to pop in an auto.key equals true so that I can actually tell what each of these points correspond to. So here you can see that not only do I have the pieces of information about sepal length and sepal width, I also have information on the species of the flowers based on the colors. So it's very clear that the setosas are quite different from the other two, because you can sort of see that the other two, the green and the pink, tend to intermingle a little bit up here, and less so on the lower right. What about looking at a distribution of a quantitative variable by a categorical grouping variable? Well, we can do that pretty easily using a box and whisker plot. So I'm going to do sepal.length by species. And now you can see that there's pretty decent separation of sepal length across the 3 species of irises here in our data set. So you can obviously take this much further than I have here, but I just wanted to give you guys a very quick sneak preview of all of the different kinds of things you can do with a data set without even getting into any of the really heavy-duty statistics.